Hi, in this video, we are going to talk about numeric data type. So, as you know, numeric data type can be generated by right clicking onto the front panel and creating some controls or indicators, or on the block diagrams, we can create constants, right? So, anywhere you create an instance of numeric, you can right click on it and you will see this uh, option over here, this menu option. On this menu option, you have something known as called as representation. In representation, we have multiple types of ranges that we can denote to numeric. If you browse through this, you will find initially single precision floating point, DBL, which is double precision floating point, and then extended precision floating point. But you should be aware that every range has some pros and cons in such a way that higher the limit or higher the range, the more it takes memory on the disk. As you can see over here, if I talk about double precision floating point, then it can have 15 number of decimal digits, but it takes 64 bits of memory. That is 8 bytes of memory storage in your system. But again, if you have the requirement of 15 decimal digits, you can use it, right? Similarly, in extended precision floating point, we have 128 bits of storage that it takes, and the decimal digits varies from 15 to 20, varies by platform. Varies by platform means whether your system is 32 bit or 64 bit. Again, then we have complex single precision floating point. Complex is your element data type in which you can have real and imaginary part, which is iota part, right? Again, it takes 8 bytes of memory. It can have 6 decimal digits of data, and so on. Similarly, here you can check what is your requirement, what is the range that you required for the specific element, and based on your range you can select the proper range, correct, or the proper data type or the representation of your data type. So if you have the range of, let's suppose, -128 to 127, you can select I8 and it will range the data from -128 to 127. It will only take 1 byte or 8 bits of memory space, and it has 2 decimal digits, right? So, but one thing that I want to convey over here is, if you have misinterpreted your data and your data generated data lies outside this range, then it will overflow. What is meant by overflow? Let's suppose if your data goes beyond 127, then it will again cycle the data, and let's suppose your data is 127 plus 1, which is 128, but 128 is outside the range, then it will automatically goes to -128. It is a cyclic thing. So 127 plus 1 is equals to -128. 127 plus 2 is equivalent to -127. So this is how overflow works. So you have to make sure you have to correctly interpret your range. If you have a range which is more than 127, then you can go to I16. It has a range of 32767 to -32768 to 32767, and so on. We have I32, we have I64. So these are numbers which range from negative to positive. But you are sure that you don't have some negative numbers in your system that you require, then you can use unsigned integers. So it is as same as signed integers, but these integers do not go in negative direction. Instead, they have the same range in positive direction. That is, in U8 we have a range of 0 to 255. In U16 we have range from 0 to 65535. So you have to choose accordingly as per your requirement, as per your specification, which range that you want to select in your numeric data type. Range selection is an important step because it takes a lot of memory space if you have taken DBL everywhere and you don't need it. So choose wisely.